Okay, right now in question B, they say that prove the following identity. Now that identity on the left hand side, it's sine 90 degrees plus theta multiplied by sine squared theta minus 180 degrees minus cos cubed 180 plus theta over cos theta minus 2 sine squared theta equals to cos 2 times theta. Now in that question then I presume that these are the identities that we may just need to use. So the first one, seeing that there's a cos to theta, so there's gonna be a point where we're gonna need to use a double angle probably. So I'm gonna write double angle identity, right? Double angle identity. Now the one that I'm gonna do is gonna be cos of 2 theta. And now remember, cos of 2 theta has three kinds of double angle identities. The first one is cos squared theta minus sine squared theta. And then the second one is gonna be 2 cos squared theta minus 1, and the last one is gonna be 1 minus 2 sine squared theta. 2 sine squared theta. And then I also see that we're gonna also use supplementary angle, that Cartesian plane there. So the other one that we're gonna use a Cartesian plane, right? Now remember, according to the Cartesian plane, we just have a theta there, and we have 180 minus theta, and then here we have 180 plus theta, and a 360 minus theta. Okay, and now remember that in this quadrant here is that all students take computers, meaning that sine will be positive and the rest of the other functions. So here sine, cos and tan, they will all be positive. But for the second quadrant, it's only sine that's going to be positive, and the rest of the ratios, which is cos and tan, will be negative. And then in this one, it's only tan that will be positive, and then in that one, it's only cos that's going to be positive. And then the other ones that I also see there, I also see co-ratios. Now, according to co-ratios, using a different color, green. Now, according to co-ratios, if you're gonna have a sine of a 90 degrees plus theta, right? If you're gonna have a sine of 90 degrees plus theta, you're gonna basically have a cos of theta. And then another one, that if you have a sine of a 90 degrees minus theta, you're gonna still get a cos theta. A cos theta. And then if you have a cos of 90 degrees plus theta, that one, if you're gonna say a cos of 90 degrees plus theta, that one is gonna be minus sine theta. And then if you say cos of 90 degrees minus theta, right, that one is just gonna be sine theta. All right, yeah, and then so far that's the ones that we're gonna use. And then the other one, I see that is also sine 30 minus theta minus 180 degrees, right? And that other one, that sine of theta minus 180 degrees, it basically means that your sine theta will be, so you're gonna have actually a minus sine theta for that one. because that answer for sine theta minus 180 degrees, it's gonna be, let me see that answer. So let's just say you put it in a special angle and you subtract it. It means that your answer is basically going to be on the third quadrant. And remember, on the third quadrant, it's only 10 theta that's actually positive. Because in the place of theta, let's just say you substituted 30 degrees. So if you say 30 degrees minus 180, can you see that the answer that you get, it's actually minus 150. And that 150 is going to be probably around here. That minus 150 is going to be probably around that quadrant, because you know that according to trigonometry, your trigonometry goes counterclockwise. Now if you're gonna go theta minus 180, we are basically now going clockwise. So that means that theta minus 180 degrees is going to be basically beyond the fourth quadrant. I hope you understand that. Now let's just go into that question. So in that question, we're going to see that the left hand side, now remember, we find that sine 90 degrees plus theta is going to give us cos theta. So we're going to say cos of theta. Then remember, I said that other one is going to be just minus sine theta. Then I'm going to put that in a squared, right? And then I'm going to say minus. Now remember, cos of 180 degrees plus theta, it's only 10 theta that's going to be positive. So this means that it's going to be minus cos of theta. Then I'm going to put that in a cubed. Then I'm going to say all over cos of theta, right? Minus 2 sine squared theta, right? Now, so now I'm going to have a cos theta multiplied by sine squared theta. Because if you put anything inside of a square, it's going to be positive. Even if you were to put -1 inside of a square, it's going to become a positive. So if you put any number, whether it's a positive number or a positive anything inside of a square, it's going to always give you a positive answer. And then that one, it's going to be just plus. Remember, it's a cube, so we're going to have a plus cos cubed theta. And that is all over cos of theta. Then we're going to say minus 2 sine squared theta. And then now what we can do, we can take out cos theta as the common factor. So we're going to take out cos of theta as the common factor. And if you do that, we're going to be left out with sine squared theta plus cos squared theta, and that is all over cos theta minus 2 sine squared theta. Now can you see that those ones are going to actually cancel out? Then now we're going to be left out with sine squared theta plus cos squared theta. Remember, I put that in a bracket, then it's going to be minus 2 sine squared theta. Oh, and then another identity that I forgot, that I didn't see, that we're going to use, it's this one. We're going to use the Pythagorean identity. Pythagorean identity. Now that one states that if you're going to have a sine squared theta plus cos squared theta, the answer that you're going to get is going to be 1. And then if you want to have sine squared theta alone, it's going to be 1 minus cos squared theta. And if you want to have cos squared theta alone, it's just going to be 1 minus sine squared theta. Alright, so we have that sine squared theta plus cos. So that answer now is going to be 1 minus 2 sine squared theta. Now can you see that from our previous question we identified that cos 2 times theta its identities, it can either be this one, or it can either be that one, or it can either be that one. But can you see that here we actually have that one? So now we can conclude and say that that one is going to be 2 times theta. Then we can now just say that equals to the right hand side, because the right hand side in this case was going to be the, sorry to say that the right hand side was going to be equals to theta. So yeah, this is how you could have actually done that question. So you're gonna use that identity there to prove at the end. So this is what we needed and all of that to actually try and simplify or prove that identity there. All right, I hope that makes sense to you.